Alright, now let's proceed on our knowledge of Venn diagrams. Now let's look at this next question. It says, in a survey of students, it was discovered that 76 like history, 98 like geography, and 87 like mathematics. 15 like all the three subjects, 39 like history and geography, 37 like history and mathematics, 48 like geography and mathematics, and 45 like none of the subjects. Show this information using a Venn diagram. Alright, so it may look complex, like a lot of information, but all we need to do is to take it one by one. Of course, as I've earlier mentioned, the first step is to draw your universal sets. Alright, that's always the first step. So I'm going to make it big. My universal set is going to be a bit big. So let's say this is my universal set. I just draw a big black box. This is where everything will be put inside. Okay, so let's proceed. Now, inside this universal set, I'm going to have different items. Now I need to ask myself, what are the different parameters I have in my universal set? They are talking about students and different subjects. We learn about history, they talk about geography, talk about mathematics. They are talking about three items. So which means this Venn diagram is going to contain three circles. Three circles. Three circles. So how am I going to draw these three circles? So I have one circle here. I'll have another circle here. And I'll have a third circle at the bottom. That's how it's drawn. So we can take time to practice it, but it's not difficult. So these three circles, each of them will represent one thing or the other. So let's label it accordingly. We are told one of them is history. So this circle is for history. This circle here, I will say, is for geography. This circle here should be for mathematics. So when you have been able to draw the universal set and the subsets, you've gone somewhere. You've gone some distance in understanding the problem. Don't forget that this is your universal set E. Alright? We are not told the total number. In fact, if you look at the B part, that's what we are looking for. How many students took part in this survey? So we don't know how many people are in the universal set yet. But let's continue solving first of all. Now, we are told that 76 people like history. So it means in the category for history, I'm going to turn that to 76. Alright? So there are 76 persons here that like history. Okay? So let me reduce the size of my pen so that it won't be so difficult for us to write all we need to write. So 76 persons under history. Alright, that's good. And then 98 persons like geography. I'll put it here. 98 persons like geography. And 87 like mathematics. So I'll put it there as well. 87 like mathematics. Now, pay attention. 15 like all the three subjects. All the three subjects. So I'm going to look for what part of the circle touches all areas, or rather, what's that part of my set where you see the three circles overlap. If you look at this very area, I will shade it first. This very area here that I shade in yellow, you notice that part of it touches the history circle, part of it touches geography, part of it also touches the mathematics circle. So you see that particular place, that is the place where all three subjects meet together. So I'm going to put my number of students there, which is 15. This is the student that like all three subjects. Alright, 39 like history and geography, which means look at the box, your diagram. Where is the intersection between history and geography? Where do history and geography, where do they meet? If you look at it very well, you see that it's here, history and geography. This is where it's for only history and geography. That is where they overlap. There's no other place in the circle that is for history and geography alone. So that place I just highlighted shows you where history and geography is. So I'm going to put the number of people that like history and geography, which is what? Which is yes, 39. 39 people liking history and geography. Now, let's proceed. We are told 37 like history and mathematics. History and mathematics, 37 persons like history and mathematics. So what am I going to do? Now, where is history and mathematics? If you look at it very well, this is where history and mathematics, this is where they meet. Alright, history and mathematics. Alright, so what am I going to do? I'm simply going to put that information there. 37 people here. 37 people like history and mathematics. So 48 like geography and mathematics. So this other section here, this is where geography and mathematics meet. So I'm going to put in 48 there. So 48 persons are here. 48 persons. All right. So 45 like none of them. So I'm going to put it just outside here. 45 persons like none of them. Now, we are going to show this information in a Venn diagram. So this should have been my complete answer. But there's something missing actually, because in my information I have, some factors are overlapping. For example, I'm told that the total number of students that like history is 76, and I wrote it down. But if you look at the diagram, inside these people that like history, there are some that like history and geography. There are some that like all three subjects. So looking at it, you see that you have to know the people that like only history by subtracting those that like other subjects apart from the history. So I need to be able to find the number of persons that like only history. I also find another person that like only geography. I find another person that like only mathematics. So how do I how do I go about doing that? So first of all, let me talk about the inner circles too. If you notice these circles I'm about to shade, this place here and here, those are the points where two subjects, a student likes two subjects. Like this first one, they like history and geography. But if you notice, inside that history and geography, there are some who like history and geography, but they also like mathematics. They are inside this 15, among these 15 students. So for me to really know how many people like only history and geography, this is what I'm going to do. Since history and geography, I have that they are 39. But I have that history, geography, and maths, they are 15. For me to know how many is really history and geography only, I'm going to subtract 15 students from it. Those 15 students are the ones that like history, geography, and maths. I want only history and geography. So I'm going to have 39 minus 15 students, which means that this my inner box here of 39 students is supposed to be, I'm going to write 15 here. Sorry, 39 minus 15, which is 24. 24. So this 24 represents those that like history alone and geography. Because if you look at it, if you add these two circles together where history and geography overlap, all of here, if you add everything here, it's actually 39. All right. So I'm just trying to separate it further, whereby we know those that like history and geography alone, and we also know those that like history, geography, and mathematics. That's what those two circles represent. So it's the same thing I'm going to do for this circle as well. This 48 is for this entire circle of geography and maths. So if I want to know only just this geography and maths alone without history, the third part, I will also subtract 15 from it. So that's how I get these inner circles. So these inner circles, I'm going to subtract also. I'm going to subtract 48. I'm going to subtract 48 minus 15. All right. So let me write this one back first for 24. So I'm going to also subtract 48 minus 15. And if you subtract that, will give you 33 students. So this place is 33 students that like only mathematics and geography. So permit me to erase this. Sorry, I made a mistake with my erasing. I'll draw some of these things back. All right, sorry for the cleanup. All right, so we have this. So this is 15 in the middle. Okay, let me change my color. So this is 15 students that like all three subjects. So at this middle here is this 48. I'm going to cancel this 48, and it's now 33 students that like only geography and mathematics. 33. So you notice, for you to get these outer circles, you just minus these inner circles first of all. All right. So the same thing applies for 37 here. I'm going to minus 15. 37 minus 15. That will be 22. That tells me the number of students that do only history and maths without doing geography at all. So I'm going to remove that 37 you are seeing, and I'm going to replace it with what? 22 students. So at least now we have been able to represent the data more accurately. We have been able to represent the data more accurately. But then again, if you notice what we have, if I want to know those that do only history, I have to remove everybody that is here to know those that are remaining in the other part of the circle. That's how it goes. So I'm going to subtract 76 minus everything that is there. So I'm going to have something like this. Let me also clean where we are working on so that it won't get confusing. If I want to know those that are in history alone, I will need to do what? 76 minus 24 minus 15 minus 20. All right. So minus this 24, 15, and 22. If you sum them, they are going to give you 61. All right. So this is the same as 76 minus 61, which is 15. So it means that the total number of students that are here alone, total number of students that are here, history alone, will be just 15 students. That's the beauty of Venn diagram. So there are just 15 students here. So this circle still satisfies what we are told here, that 76 people like history. Because if you count around this entire circle, all the numbers inside this circle, it will still be 76. We are just trying to separate it so that we know the people that like only history or only something else. All right. So the same thing is what I'm going to do for the geography. I'm going to minus 24, minus 15, and minus 33. That is to say everything that appears in this yellow circle of geography, I'm going to remove it as well. So when you subtract everything like as well from the geography circle, 98 minus all of this, if you punch it in your calculator, you're going to be left with just 26. 26 people that like geography alone. We'll also do the same thing for mathematics. We'll have 87 students in mathematics minus every other aspect that touches the mathematics circle. All these aspects, we are also going to minus them from the mathematics circle. So we're going to minus 22, minus 15, minus 33. That's how you know what's truly here. When you finish minusing, you see that you are left with not 87 but 17. All right. So that is how to represent the information in a Venn diagram. So yes, a three-way Venn diagram may be more complex than a two-way Venn diagram, but it's all about understanding it. So the key is when you have always start from the center, the very center. So when you have another, let me draw another random diagram. So when you have a Venn diagram containing three aspects, always start from the center where they all overlap. All right, where the three overlap, which is here x. When you start from the center, you can, if you are given this, maybe this is y. For you to get what is really here in y, you subtract the x from it. If this is z, you also subtract x minus x. If this is p, you also subtract x. So then you push out again to the outer bigger circle. If this is a, you have a minus, you are going to now subtract everything that is here with the a. Everything that is here with the a, subtract it. And then if this other side was b, you are also going to subtract. You are going to have b minus every other thing that is disturbing the b. Every other thing that is in this circle, you minus it. And then if this other side is c, it will also be c minus every other thing that is here. Every other thing that is here disturbing it. So that's how we get exact information in our Venn diagrams. So in the next example, I'm going to show one example that explains how to solve a question like this on Venn diagrams.